Navigate.
Hey guys and gals, how you doing? How are you doing this fine day? Let's go! I love getting you excited, pumped up. Just like usual, bear with me. I'm gonna check, make sure we're good on the stream. I love getting you excited. Yes, we are. Awesome. Turn it up. Turn it up. Okay. How is it going today? How's it going? I must ask you, is your day going well so far? I certainly hope it is. Let's see, what am I doing here? I'm just gonna go right through shout outs and such. I don't want to spend too much time going through this document. Okay. Alright. Let's do this. I'm trying to get excited for learning. Yeah. Yes. Guys, just doing mod stuff right now quickly. Trying to get that out of the way. And then we will get to doing some learning. Here. What am I looking for? I'm looking for shouty outies. Shouty outies. Let's go. Shout outs to the latest supporters. Here on Twitch. Let's go. You guys are awesome. Thank you for the support. I truly mean that. Whoever's viewing the content and watching the content, man, you are so awesome. You truly are. You're the greatest. You are the greatest. I love it. Thank you for being part of this, learning and growing alongside with Johnny Tango, WhiskeyTango Coding. I truly appreciate it. I really do. It's you guys and gals that keep this train going. Let's just say that. It's you guys and gals that keep this train going. Mind you, I'm going to always be learning and working, so it doesn't really matter if I'm doing it live or not live. But appreciate hanging out with you guys and having you guys hang out, listen to me, watch my content. Much love for that. Let's quickly shout out followers, supporters of the channel. Nicole Trace 66, Bart number 1, Jim Jam 1238, Kazards 20, Gavin 555. Kamikaze! ML, I hope you're still doing good, Kamikaze. Appreciate you being around. Much love, brother. Ducky! Yeah! Ducky. I gotta do this. Hold up. You can thank Ducky for the quacks. You guys love it, you know it. Thank you for the support, Ducky. And lastly, latest follower here on Twitch, Wicked Stat. Also followers on YouTube, because I know some of you are watching as well. You guys, I appreciate you as well. Just the same. WX87, Flawless Hack, Salt of the Earth Ministry, great to have you, brother. And Aya, is it Aya or Aya? That almost could be a variable. Appreciate the support on YouTube. Thank you for watching the content as well, wherever you are. Let's go. I am live on Twitch, guys. Yes, I am. And because, well, the videos don't last forever on Twitch. Lucky for you YouTubey peoples, I'm transferring or exporting my Twitch content up to YouTube just for, because this stuff takes time. And time is money, and money is what I don't have. Isn't that awesome? Yes, it is. It's great. Great feeling. Along with the new neighbors. Oh, yes. I don't want to get into that, though. Literal revolving door. Literal. Okay, all right, you guys, there we go. I guess I could do this quickly, and then we're gonna get into learning. I just want you guys to know that I care. Okay, I care. I do. Okay, I want you to know. I'm not gonna be one of them people that just takes you for granted. Okay. Your views and your support means a lot. That's right. Every single one of you. That is for you guys and gals. That's my fam in the background, my imaginary friends. Putting the cheers on for you. I love doing that. That's for you guys. All right. I think it's time. Time to get the old learning. Flick that switch in the old brain molecules, It's time to learn, guys and gals. You ready? I hope you are. Let's learn, okay? Learning is fun. It is, okay? You're not filling your brain with waste, okay? Like majority of the world is doing. Now, again, guys, gals, those of you that are watching the content, you guys automatically, instantly, okay? I already know that you're intelligent and smart and beautiful, intelligent people. Just because you clicked play. All right? Let's just be real. Okay? The other type of individual is not going to click the play button, okay? It doesn't have the right title. Oh, learning! Oh no! I must run away! I'm gonna go convert my cat into an elephant! Learning! No way! I can't learn! I'd rather gaslight! It's all I know how to do! Okay. Alright, enough of that. Constants! We were working on constants. We talked about literal content. Blah, blah, blah. Constants. Literal constants. We were trying to figure out what are literal constants. Oh, well, look at that. There it is, right there. That's a literal constant. Things you learn, isn't it great? Terminology, theory stuff, you know. I see this, I know what it is. My brain sees this and it goes, declare, initialize, declare, initialize, declare, initialize. It also means left-hand side equals right-hand side. Left-hand side equals right-hand side. Right? Something else we need to kind of talk about. Right? What is happening when you type a line like this, guys, gals? Okay, this is critical stuff, right? We are going to get into it more memory stuff, but, you know, we'll talk a little bit about it so that by the time we get into talking about memory and that area is going to be like, wow, this is, this is easy, you know what I mean? Because it's not going to be new, right? That's why I kind of incorporate these words and coding lingo into the, our lecture, right? Our free class, okay, which is great. It's awesome. And then you kind of get to know these words and the lingo ahead of time so that by the time we get to the actual, area in this course outline, it's just going to be breezy, easy breezy, lemon squeezy, So right here, what is happening, okay? Left-hand side equals right-hand side. Hopefully I actually typed that in the correct order this time. My brain must have been backwards that day. Okay, so when we declare, we're declaring a data type. Okay, what type of data is it we're using? Well, we want to use integer type. And again, hopefully, I usually always say this. Hopefully you didn't sleep in mathematics class because math is great. Okay. Integers are whole numbers. Whole number? What's a whole number? Well, it's a whole number. I'm not going to get into that, right? You guys and gals should know this stuff, right? Basic mathematics stuff. And then the next thing we do is we create a variable. It could be any type of name. You could name it cat's toenails. I mean, you can name it whatever you want. You get to create it. You're the creator of the names. Okay? And then what we're doing here is we got to make it equal to something, right? Give it a value, because anytime you do a type of statement, I got to get into the groove here again, guys. So bear with me. Okay, we're initializing a value. All statements, for the most part, all the time, need to be initialized. And it doesn't matter if it's got to be something, okay? And then obviously it has to be a whole number value, right? So here it's telling me, to do something. So it's giving me a hint. Local variable is not initialized. This is all part of the coding lingo, right? So that when you're actually debugging your code or reading whatever it's saying in the error list, now you understand what it's telling you, right? and you'll be able to, fix your little bugs or your little syntax errors or minor mistakes, because really that's what they are. They're just silly little things. Sometimes we just do silly things. And so it needs to be a value, because otherwise, prior to this is my assumption, prior to whatever standard you're using, I know 3 years ago when I was starting out doing this variable would be holding basically garbage. What would look to us like, just visually, as, I don't know, I'm just gonna type some random stuff, okay? Hexadecimal type lingo, right? But really it's mostly just garbage, okay? Just a series of whatevers, and we called it garbage. So the variable itself would be holding information, right? Again, if you've been following along, you'll understand that when we create this variable, it gets kind of put onto the stack memory, which is your RAM, or your, i.e., temporary memory, okay? Every memory location has a memory address, right? Typically, normal hexadecimal values will look like normal memory addresses, I'd like to correct myself, would look like normal hexadecimal values, not just random garbage stuff. So my point is, initially, if you didn't initialize this variable to something, it would store garbage. So if you actually tried to print it out, it would return this kind of, to the console, it would return some blah, 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 blah. Just random information that our brain doesn't understand, right? So that's why the program's like, you got to initialize it. You got to give it some sort of value. So when it gets stored on the stack, I'm going to use this lingo over and over again so that it's kind of trained in your mind, because this is all part of the coding lingo. You start working with others and such, people that you work under or whatever, they're going to use this type of lingo, and you're going to understand what they're talking about, okay? So there's two ways to initialize. Obviously, we make it equal something. The most minimum value that you could give it is a value of 0, right? At least you're giving it something. And 0 it's the common whole number that would be used, okay? So now we have it initialized. It actually has a value. So if we return it to the console, it's going to return 0. Okay? It won't actually say return 0. It'll just return 0. Right? That's what you'll see when we run the code or run our compiler. Okay? All right. So this would be called a literal constant. So they're saying that it's a constant. Myself, in my thinking, I wouldn't think of it as a constant. I would just think of it as a whole number value, right? But I mean, it doesn't hurt to have this extra additional knowledge in our mind. Okay, that's a literal constant. You could use that kind of lingo if you want, right? That's entirely up to you. I just go like this, declare initialize, and then left hand side equals right hand side. So when we're talking about memory a little bit, we're getting into the kind of the finer little details. Excuse me, guys. Getting low on coffee right now. As you advance more now, you're going to be learning about like left hand side and right hand side, and you might as well have an understanding of it now, or at least be aware of it. It's kind of knowing about it, sort of thing. You don't have to go full on deep into the details of understanding, but knowing about it is a good thing. Okay. So what is happening here is this variable. Okay. Like I said, it has a memory address, and now it's also what you can call a container. And since we're talking about that, I'll bring up that image so that you can have a visual. Looking. I saved that visual. There we go. Okay. Right, containers. Okay. So memory, i.e. RAM, i.e. temporary memory, stores information in a series, right? Or in a linear fashion, however you want to look at it. It's kind of like taking a whole bunch of cardboard boxes and putting them beside each other, okay? Each cardboard box is a container. Each cardboard box is also a memory location. Each cardboard box has its own address. Now you could look at a cardboard house, you could even, instead of thinking of it as a cardboard box, you could think of it as a house, right? Every house has an address, right? So these are all different houses on the block. Okay, you'll hear the term memory block as well. Okay, this is having a better understanding of what's happening under the hood, guys. Okay, so we would also call this stack memory, okay, or compile time. It's all before runtime, but anyways, and then the value that we give it gets put inside. Okay, so the container is holding that value of 0. Okay, it does a lot of things, guys. It really does. Okay, if you're watching yesterday's stream, and I hope you have, each position, each memory address also has a position. This kind of all relates to how the compiler accesses information, or the CPU for that matter, how it accesses information from its RAM or temporary memory. Another way to look at it is, in quotes, library. Like, think of it as a librarian. When the compilers run, the librarian goes to the book location, right? However you want to look at it. Okay, I'm kind of going, I don't want to go into too much analogy, but you can look at it however you want. And then the librarian organizes each, shelf or container, right, in an order. It has a position or a location, right? Okay, I'm just going to leave that up. And so the memory address is actually stored with the variable, okay? This is kind of key to understand. So the memory address, so when the compiler does its thing, it sees the variable, it goes to the memory location or address that is associated with this variable. This value, bear with me today, guys, this value gets put inside the container. So left hand side equals right hand side. So here's the reason why I kind of went into all of this. The variable is what's holding information. Okay, that's the left hand side part. This is kind of a little bit critical to understand. Okay, the value 0 has nothing. It's just integer value. It doesn't have anything. It's just a number. That's it. So the right hand side basically has nothing, if you will. So the point being is, it doesn't have a memory address. It's just a number. Okay, so that's the key thing to understand. The left hand side is what has all the information, the direction of where the compiler should go to access information. And then when it gets that information, it goes, oh, it has this inside the container, okay, which is a whole number. Okay, so that's the main point. The right hand side really is just, it could be anything, right? I don't want to call it just a number, because it could be more than just a number, right? Because you have different data types, right? And different other things that can happen as well. once you get more advanced with coding and that, you'll learn more things, right? Different concepts. Okay, I know that was a little bit, and it seems like it's kind of, I don't know, trivial or whatever, I don't know. But I think this is kind of the hardest thing for people to kind of grasp. So bear with me, guys. Just please understand that, some of you might get it really quick. You might grasp it really fast, which is great. But others, because sometimes it could just seem confusing, okay, in simple terms, right? So I'm providing that little extra teaching, instruction, kind of support. Just if it seems like I'm over-explaining, just please bear with me, all right? I'm doing this for everybody across the board. Again, if you already kind of understand and maybe you already know how this works, it's great to have you. It truly is. We're going to get into more stuff. So you could either skip forward a little bit in this video or carry on to the video that is in the future. In the future. In the future. In the future. All right? Okay, cool. All right, so I went over all that because I want you to understand what the left-hand side is doing and what the right-hand side really is, okay? Just to give you that little subtle differences, right? Because you'll see this left-hand side, right-hand side stuff, and then when you start getting into pointers and referencing and dereferencing, it'll just be so much easier to understand, okay? That's why I'm going over this a lot, okay? We aren't quite at the referencing, dereferencing, but by the time we get there, you're going to be like, man, this is easy, right? And that's the goal, okay? Cool, you're awesome. All right, that was a little bit. So, again, yesterday's stream, I'm going to try to kind of push forward here now, get into the course outline. I thought I would go over that a little bit. So, literal constant, right? So, we could give it any value. They're calling it a constant. And my thinking is when you run a program, you could have this value change down somewhere in your code, somewhere within your main, right? The value could be changed or updated, and then it gets saved back into the memory or into the variable name, okay, or the memory location, however you want to look at it, right? Just take note that the variable has a memory address, and it's a container that holds whatever's on the right hand side. Man, my throat today. I almost want to go. I drank most of my coffee before I started the stream too. I might want to get some more coffee. I need some coffee because I'm having difficulties talking today. Excuse me, guys. I should have muted maybe. Thank you for your understanding. I literally just slammed my coffee, which is sad face because now it's an empty cup. And I don't like empty cups. All right, let's continue. So then we talked about symbolic constants. Okay, we're just going to kind of go over it quickly. It is recommended that you create a variable and then assign it a value, okay? I really don't want to go over the stuff we went over yesterday. I guess I should recommend, just if you haven't seen it yet, check the prior video. I do recommend that you follow this like a series. We're kind of doing a course outline lecture here. Again, look at it like a class, a free online lecture. guys, I'm going to explain things. I'm going to go show examples. There's going to be a lot, okay? This isn't one of those 5-minute video channels. How do, see, do, show me how do, but no understand, no, don't understand, no how. But see, do, how do, know how do, but don't understand how do. Okay, you know what I mean? You feel me? Okay, who wants to hire know how do but doesn't understand know how see? Explain cannot explain know how because they only know how do but cannot explain understand how. I know that was a lot, but do you kind of feel me? You getting me? I know I wouldn't want that person. Okay, if you don't understand, like anybody could be seen how to open a car door, but do you understand how that car door works? Right? I know that was kind of a simplistic example, but that's kind of what I'm getting at. All right? I mean, if you don't understand the theory and stuff, you kind of cheat and shortcut the system because you're being lazy. I'm not saying you guys that are watching, but there are people out there like that. We know this. They shortcut the system because they're lazy and they don't want to put in the hard work, right? And then they become a DEI hire. Oh my God. All right. That was a little much, I know. But, so, yeah. Put in the time, guys. Put in the time. Show your worth. And you'll feel a lot better about yourself putting in the time, too. You will. You'll be proud of yourself. You really, truly will. Okay? Builds character. Okay. So instead of doing something like this, I'm just going to kind of quickly, okay, we need to carry forward here. Instead of doing something like this, and then you have this down the code somewhere, it could be somewhere way down here, right? And let's say in the future you decide, well, the number of classes or students equals, I should have had a multiply there, equals classes times, I don't know, however many students per class, right? Let's say that value's changed in the future. Well, if you don't declare it, right, students per class, the main goal is to declare it ahead of time so that you only need to change the literal constant right here in code. And then so you take this and you replace that 15 with students per class. Okay? That's the general concept. So imagine this is line 7,893. Okay? You're going through like a lot of code just to find that number 15. Okay? Who wants to do that? Do you? I know I don't. I'd rather be able to just change the value right here at the top, right? So that's why we talked about symbolic constants. Okay, I need to move forward. We also got into enumerated constants, kind of reviewing a little bit quickly, but I want to kind of push forward here. And we talked about memory location, right? So this is the position. Did I close that? I guess I did. Okay. So each memory or container or memory location, which has an address, right, which is normally in a hexadecimal format, also is a container that can hold numbers or values or whatever data type it is that we're using. Okay, it's a container. It holds that number. If we're using integer, for example. Okay, but also, now, this is the key concept of why it is explained how how memory works, and you'll hear the term contiguous memory. What that means is information is stored in contiguous blocks, in order, in series. That's what it means, contiguous. Okay, so it's a lot to kind of explain, and I'm trying to make it easy to understand. I'm trying. So each box or container has a memory address, right? Because it's kind of like a delivery guy. Delivery guy can't get to the house if they don't know the address, right? So when the program is run during compile time, then runtime, the CPU, whatever's happening under the hood, has to access that information from our RAM, or temporary memory, or library, or however you want to call it. Okay, so inside's holding a value, but also it's a position, right? So that's why we talk about how computers count. Computers count starting with 0. So if you think of computers like binary, zeros and ones, if you think of computers like that, you'll always remember that computers start counting at 0. This part's kind of important, because when you start working with arrays and stuff, okay, so it does have a memory address. That's where it knows where to go, but it also, each box has a position. Position 1, position 2, position 3, position 4, position 5. It depends on how much, right? Remember, each one of these is a byte. 1 byte, 1 byte, 1 byte. So if it's a 4 integer byte, or a 4 byte integer, it's only going to have 4 containers. Okay? So just remember that the containers, memory does a lot. There's a lot of things happening, right? So you just kind of have to organize it in your head, what numbers and values are, right? You'll see it written in code here shortly when we get there, guys. Especially when we get to arrays. We'll be going over this again and again. This is to kind of secure and to solidify in your brain or in your mind while you're learning, which is great. You'll understand the concept so much quicker. Yes, we're kind of going over it and over it and over it, but also repetition is good for storage, in your own mind, right? So computers start counting at 0. We also use the term index position. So if you hear position or index, that's what that number is. So 0, 1, 2, 3, 4. So you could actually pretend you're writing it with a marker, right? You could put the address on the front of the house. You could put the position with a marker on the inside. So you would write a 0, you would write 1, you would write 2, you would write 3, 4, and so on. And then whatever gets put inside, like an integer value, just gets thrown in like a dice into a box, right? You're just throwing the value in there. The container is holding it. Okay. I hope that made a lot of sense. All right. So the reason I said that is because we're going to be doing something here. Hopefully you guys practiced this yesterday. I'm not going to do that anymore. Okay. That's how you can figure out how much memory, right? The size, right? If I run it, I should get 4 because we are being explicit about it being an int, right? 4 bytes. So 4 containers, right? Each container is a byte. So remember that too, right? Okay. So enums. Enums, I know like arrays. We haven't got into arrays, but by the time we get to arrays, it's going to be easy for you. This is kind of leading into arrays a little bit. So if you notice here, you can see that 0, right? That's why we're talking about this. This is kind of reviewing, but we're also kind of expanding on this today, okay? If I hover over blue, you can see, oh look, there's the index position I'm talking about, Right? I'm not talking for just for the sake of talking, trying to sound like I'm good and knowledgeable. I'm trying to actually help you guys see this visually, what these numbers mean. Okay? There's a method to my madness. And I appreciate you being here. I truly do. All right? Green has the position 2 or index position 2, right? Remember, computers count starting at 0. Think binary, zeros and ones. Us humans, we count starting at 1, right? That's us humans. But you got to kind of separate computer thinking from human thinking, right? Okay, awesome. All right, and you can see white is 3 and black is 4. You could actually change those values. So I could actually reassign, which is kind of cool. I could actually reassign these values to have a different position number. And I'm going to show you something cool here. It's really neat. So if you noticed, I skipped blue. But you'll see what happens here. This helps you get a better understanding. And then we're going to go black equals 700. So check this out. I don't need to build it, but it's just habit. So check this out. So now if I hover over red, look. Red is now, it's so finicky to get there, to hover over this. Now the index position or position is 100. Cool, huh? So what's going to happen if I hover over blue? What do you think? Think of counting, guys. Think of counting. If blue doesn't have a number, if we didn't reassign it a value, well, then blue's going to be 100 plus 1. Isn't that pretty neat? Check it out. So we could actually add in between, if we wanted, a whole bunch of new colors, right? I could go, I don't know, let's go indigo. I'm just going to go with another one. Okay. So now I've added another one. I'm actually building and expanding on my enum or enumeration. Okay, 100, 101, 102. Pretty awesome. So this could be our starting point. So all these colors, type of colors, belong in 100. And this is just for an example, right? You would kind of probably organize your colors a little bit better because you could have variations of green or variations of blue, right? So green, if we hover over, obviously we assigned it the value 500, so that's what it's going to be. Position 500, if you will. Okay, and just like back here, white should be 500 plus 1. And then if we added another, I don't know, let's say peach. Okay, that should be 502. And then of course black is going to start at 700. Okay, because that's what we kind of told it. So, I mean, you don't have to do this. You could have it as 0, 1, 2, 3, 4, 5, 6. You could, right? Or you can also reassign it if you want. So let's just do some quick reading. So the syntax for creating enumerated constants is to write the keyword enum followed by the new type name, which you can see, right? We gave it a name. The name is color. Look, you can, if you hover over it, it's actually still holding 4 bytes. If you were wondering that, right, are you creating more containers, if you will? Well, enum's still going to hold 4 bytes. Everything's kind of condensed in memory, however it is. We all can't climb into it, into a RAM and have a look. It's kind of impossible. But in a sense, the index position is a way for the computer to be able to kind of access that position in memory, if you will. Okay, and you can change the value. All right, let me just continue reading here. Each of the legal values separated by a comma, right? As you can see, right? Notice the syntax. Writing code is very repetitive. Not all the time, but you can see there's a certain way to write and type each statement. Okay, so certain things belong, like commas, the semicolon, that belongs. Those are all important little details. The commas create separation, right? Okay, and then of course you got your opening and closing braces, always. This statement performs two tasks. Okay, it makes color the name of an enumeration, that is a new type. Okay, and enum is a type. It makes red a symbolic constant with the value 0, right? Well, we changed it. Let's put it all back. I didn't really need to show this, but just so you know, you can do these sort of things. Okay, so now that I changed it, everything should be right. Remember, it starts from 0. Always remember this, right? Because when you run your program, the magic that's happening under the hood, it actually accesses that value, that position, right? Okay, and you can actually add to that position, right? So we got 1, 2, 3, 4, 5, 6. Okay, you'll see how it works when we start writing extra statements and then accessing that code or accessing that information through code. You'll see, okay? Okay, so red is symbolic constant with the value 0, blue a symbolic constant, right? These are being called symbolic constants. That's fine. With the value 1, green a symbolic constant. We've added some more, but with the value 3 now, and so on. Every enumerated constant has an integer value. If you don't specify otherwise, the first constant has the value 0, right? You can also think of it as index position. Okay? And the rest count up from there. And any one of the constants can be initialized with a particular value. However, and those that are not initialized count upward from the ones before them. So just like I did earlier, if I can undo here, maybe it'll let me. Yeah. Just like I did here earlier, right? We could do this. We could kind of, I guess, we can reassign them, okay, essentially. Okay, so the red has the value 100, blue has the value 101, right? So that's why, I'm showing this too, so you can see what happens, right? This still gets counted by 1. 100 plus 1, 101 plus 1 is 102. And then we're starting at a new index position, if you will, of 500. So white is going to be 501, and so on. You can define variables of type color, but they can be assigned only one of the enumerated values. In this case, red, blue, green, white, or black. You can assign any color to your color variable. Okay, blah, blah, blah. It is important to realize that enumerator variables are generally of type unsigned int. Okay. Right? So that makes sense, right? Remember, unsigned means no negatives. Just instead of trying to overanalyze and try to remember which one's which, just sink it in your brain. Unsigned, no negatives. Okay? Everything's positive. Okay, so, and this is true, right? The index position is an integer value. Okay, guys? That's why the information could be accessed. But we have to access it through the number, right? To see the return here. You'll see. I'll do an example here. Okay, let's see, where am I? And that the enumerated constants equate to integer variables. Okay? Again, these are being called constants, right? Look, it even says it right there, enumerated constants. And then you can click search online if you want a little more information. These programs are great. If you just hover over it, it'll tell you what it's doing or what it is. Okay, again, it's all part of the learning too, right? And then it solidifies that information being saved in your own memory banks. Let's see. Okay, it is, however, very convenient to be able to name these values when working with information such as colors, days of the week, or similar sets of values. Okay, so let's do a little program that uses an enumerated type. Okay, so I'm just going to go like this. Okay. Whoops. All right. So I'm just going to do some new ones here. All right, I'm just going to go like this. And we're going to start clean here. We're going to call this days. Okay. Now we're just going to use, stuff that we're used to, like days of the week. Sunday, Monday, Tuesday, Wednesday. Is that the day that people get married? Wednesday? I know, I'm hilarious, guys. I'm hilarious. Whoops. Okay. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So with what we just did, we should be able to hover over this and see that, oh look, right here, this is where these double colons, you must get used to this, okay, seeing these double colons. Scope resolution operator. I have to go over it. I think of this kind of in regards to classes. I'm going to kind of have to go over my notes. But it depends on how these are being used. It might have a different name. Or what could I call this? It might have a different name for what its purpose is. I know that didn't kind of make sense, but my point is it could be called something else. But for now, for classes, I think with classes, just think of it as scope resolution operators, okay? So look, I hover over this, you can see enum days. So what it means is that Sunday belongs to days. That's what those double colons do. So you look at this and you go, oh look, enums belongs to days, and that's true. Okay? But the reason I brought that up is just so you can understand what these double colons are doing. Why is it there? Why is it showing, right? Now you understand, right? Sunday belongs to days, and Sunday is equal to 0. Monday also belongs to the enum days, right? This is the type. And this would be, I look at it, I think of it like class, but it's not a class. Are enums a class? I think they are. Just like string is. String is a class. But anyways, that's kind of going deeper under the hood of understanding. Okay? So you can see Monday is 1. And so on. Tuesday is 2. Right? Again, computers count starting at 0. Always remember that. Because if you don't know this little bit of information, when you try to access this information through code, you're gonna have bugs and breaks. Okay, this number is very important here. Okay. Okay. So now we've done that. Let's type days. This is the class. It is a class. This is how it's working. So now we're creating what's called an object. Since I'm kind of typing this, I already recognize what it's doing. We didn't create a class. This is actually created for us. I could maybe view the code, right? For example, but we're not going to. You can look at the code behind, if you will, that the great fine devs that created the classes and all the background work that they do, so that we could actually type and do what we're doing here. If it wasn't for their hard work, we wouldn't be able to do this stuff. Okay? Right? We don't just twinkle our noses and the magic happens, right? Stuff has to be done in the background so that we're able to do this right now in the foreground. Make sense? So, showing here, I always think of classes, right? When we're doing this kind of stuff, it's just the way my brain thinks, right? It's still an enum, it's not a class, but I think in the background it might be. I don't know. I don't want to call it a class, but it could be. Okay. Days is the name we gave it, and we have to create what's called a object to be able to access information. Object is what makes the magic happen. Okay. And again, I could call this car doors. You know, I could call it whatever I want, right? Depends on what we're doing. I think, yeah. Okay. Today. So it has a suggestion. Oh, okay. This is where the initialization is coming in, right? So now you're gonna go, okay, double curly brackets. So what it's saying is, guys, it's telling me to initialize it by using two curly brackets. Remember, I showed you that there's two ways of initializing. We could initialize by typing 0, or we could initialize by using curly brackets. They do an exact same thing. If I go like this, and I didn't really build it yet, but we'll build it just to kind of update it. And if we look here, that took a little second. Number is 0, okay? And if I go here, well, it's showing 0. That's because we've actually initialized it. Somehow, it's not garbage right now. I don't know what the master coders have done in the background, because before this used to be garbage. But now it's not, which is great, I guess. But you still have to initialize it. So now we're here. We haven't jumped over yet, so we're jumping over. And now it should be 0. Okay? I'm going to stop this. Okay? And there we go. That's initializing. Alright? So they're holding the value 0. The number 0 is inside the container. Right, guys? So going back to this, we look at this, we see days, and we're seeing letters and words. And in our brain's like, but these are words. They're not numbers, right? This is where you have to create that separation in your mind, guys, right? I already explained this, right? That's why I said this part. Enum is a type, which is an unsigned integer. That's why you can initialize it to the value of 0, because it's an unsigned integer. Okay? Right? Understand that. This is, for us, human readable, but the computer looks at it like a number, if that makes more sense. Okay? For us, this is human readable. For the computer, it works with integers. Okay? That makes a lot of sense, right? So let's say now that I created an object, you might as well get used to the word object. Normally you don't initialize like this with objects, not through classes, but this is an enum, so that's okay. Notice how the syntax is working, right? The way we type our statements, right? This is still a statement. Okay, so now that we created an object, we could actually use that object in our code. So we're going to say today equals Monday. Okay, the program knows, it can see it. Okay, and we know Monday as index position 1, right? I'm explaining this to you guys and gals line by line, essentially, so you understand what's going on. So I haven't gone into this stuff yet. Again, here's something new for you guys and gals. Okay, if statements, right? We haven't got into that area yet, but you don't need to fully understand them or how they're written, but it's great to see it kind of ahead of time so that you're like, oh, we're doing if statements today. Great, let's go. Right? So when we're actually in the course outline of doing if statements, it's going to be, trust me, it's going to be like, man, this is another easy day. Okay? So today we're using the object. If today equals, now I'm using double equals. Let me just bring up my novel, my C++ book that I've been like slowly building here, which I still need an editor for, just to kind of do all the proofreading and organizing. Editors in my mind are the ones that are great at doing essays. I'm great at math, I'm great at calculus, I'm decent at coding. I'm not going to say I'm the best or the greatest, because I'm not going to cap, but they have an area of expertise. Okay, everybody's different. They have, right? So take advantage of their expertise, right? Hence why I would want an editor, because they have the expertise into being able to edit, modify, adjust. They understand essays, they understand chronological order. It's just their area of expertise. Okay, so getting back to teaching coding here, I have to find my area of assignment operators, just so you guys understand. We're going to get into it a little bit early here. We will be going over it again, so you might as well, learn about it now. Now I just got to find it. Bear with me, guys. I'm going through my now it's 143,000 characters, right? I built up on it. I've been slowly increasing it. I do have a table of contents, but the thing is I have this backed up in Notepad, so I don't know. I can't use the table of contents because I don't have my line numbers here in my Notepad. Okay, let me just keep scrolling here. All I could do is just keep scrolling and looking for it. I feel like this is wild. I feel like I've gone too far and went right past it. Let's see. Bear with me, guys. I appreciate your patience. I truly do. Okay, data types, which I should have shared with you guys a little bit, but I'm thinking the course outline is going to have that. This is interesting. Where did I save that? I must have moved it around. I thought I had it memorized in my head, but I just want to give you a visual. That's what I want to do. I want to give you a visual. Might have found it. I didn't realize how far into this program that it is. Okay. Yeah, okay. I found it finally, guys. Okay. So assignment operators. Oh, you did it? Oh my god. I clicked it and it went to the top. Why does that do that? That's such BS. I went to move it, my notepad, to show you guys, and it jumped to the top of the page. So now I'm like scrolling through it again. Like, are you kidding me at this point? Sorry, guys. Okay. Don't move. Sorry for swearing, but yeah, I wasn't a little bit perturbed about that. Okay, assignment operators. We've talked about some of them, right? Your basic arithmetic or binary operators are also called. There's a new one in here, the percent one. We use it in code. It's called modulo. We'll get to that. You don't really need to be too concerned. But I wanted to show you these 6 types of comparison operators. This is what I want to show you. Okay, you have they're used for within our for loops, do while loops, obviously if statements as well, right? Which we're working on right now. And we have an equal to. So when you see double equal signs, it just means equal to, okay? It's not the same as going int number equals 12. It's doing something different. It's basically kind of like a comparison thing. Let's say we have int number 2 equals 15. We're using it for comparison. So we're going to go does number equal number 2, right? You can visually see that it's not true, right? Because number is 12 and number 2 is 15. Okay, this is just as an example for you guys. Okay, so that's what the equal to equals to does. And then you have a exclamation point, and what it means is not equal to. And then the common ones that you know, less than, greater than, right? These are all from mathematics class. You should know those. Okay? And then I'll kind of go over it a little bit. And then you have your logical operators, which we'll get into. And then or. These are the pipes, the 2 pipe that is above your enter button on your keyboard. I call them pipes. 2 pipes. And they're called the or. So and or. Okay? I just wanted to touch on that quickly. I'm just going to save it the way it is. Okay, let's get back to this. So what we're doing is saying, is today equal to Sunday? Or is today equal to Saturday? This is how you have to do your if statements or your for loops and such. They have a different purpose or function in code. Okay? All right, so if today is equal to Sunday, you can just think of it as equal to if you want. Is today equal to Sunday or is today equal to Saturday? Now you can not use curly brackets, but majority of the time they're used. Now there's 2 ways of doing your curly brackets. There's this way, it's a style. Some companies prefer the curly bracket, the opening curly bracket here, and then the other one down here. And then there's companies that are going to want you to do this style. This is the style I do. Okay? So if you only have one statement immediately after, like standard CO, if it's just a singular statement, you don't need the curly brackets with if statements. Okay, so I'm going to type, I don't know, something. I should have something funny. If today is equal to Sunday or Saturday, yeah, baby, it's the weekend. Okay, something like that. Get used to me always typing tet because yeah, that happens and it's annoying. Okay, and do I end with whoops. Okay, there. And then, so I always use my curly brackets. I'm just kind of a purist, I guess. I don't know if that's the right word. I'm a bit anal about using curly brackets. So my point is if you have an if statement, inside here are essentially our arguments. Okay? These belong with our if statement, the brackets, and then we put inside our arguments, okay? Or comparison arguments, however you want to look at it. And then immediately after you have your body, that's what the curly brackets are. The body of your if statement. Okay? So the point is you could use it or depends. If you have more than one line of code, I recommend using it. Okay, so I'm going to put it inside. And then what goes with if statements, now you don't always have these with an if statement. You could have a whole bunch of if statements, right? Kind of one after the other. Okay, or you could have like, if it's one thing or is it another. So what goes with an if statement is also an else statement. Else only has curly brackets, if I could actually type. Don't mess up your curly brackets because your code will get messed up. Okay? Because like I always say, guys, the brackets belong together. This is the brother, this is the sister. This is the brother, this is the sister. Main has its own brother and its own sister. So if you have an extra oddball curly bracket, your curly brackets in code could get messed up. Alright, just as a heads up. Alright, so if it's the weekend, we're going to return this. Basically, that's what this is. And obviously, Sunday and Saturday is the weekend, right? And then if it's not, then we're going to just return something silly like, man, back to work or something, you know? Oh man, still gotta work. I love working, to be honest. When I'm doing this sort of thing, I enjoy it. Alright, there we go. So, if we look at our code here, guys, okay, I'm just gonna build it quickly. So, we've created an enum, we've given it a name, we've given it, I guess we could call these elements would be a word. So Sunday's an element, Monday's an element. They also have, they're associated with an unsigned integer value, right? Okay, and then we take our name of our type and we create an object. That's what this is. I'll use that terminology a lot. Objects make the magic happen. I always say that. And because it's an unsigned integer, we have to initialize it. That's the reason why we had to do this. Okay? You can see the curly brackets have a different purpose, right? If you look at each statement, right, the curly brackets, what they're doing here is different to what the curly brackets are doing here. Okay, so that's helps you have a better understanding of the code and what each little syntax is doing. What's its function? What's its purpose? You may look at it and go, oh, they're just a couple of curly brackets, but they're actually doing something in the background. Okay? I don't know. I don't know, whatever. It's the weekend. Yay, baby. Bye, bye. Should be like a Y or something, but whatever. It's the weekend. Okay. And then, so this object, we're basically with this statement here, we're saying that today is Monday. We're being explicit in the sense. We're saying today is Monday. Okay, so when we run the program, again, code is run line by line until it reaches a program is executed line by line in the order it appears in your source code until a function is reached. Anytime you see .cpp, just think source code, okay? Main is a source file. Okay? It's going to go here, it's going to go here, it's going to go, oh, today is Monday, and then it's going to do these checks. First, it's going to check our ifs. It's going to go, if it's, and obviously you can see here, if today is Sunday or today, so with the ors, basically one only needs to be true, okay? In order for this to be executed. Only one of these need to be true. So if I write Sunday, now that makes this true. Okay? Just so you understand. Okay? Right now, both of them are false. Okay? Because obviously it's not Sunday and obviously it's not Saturday. So when we execute this, it's going to do these checks, then it's going to go, oh, okay, well, these are both false. So then it goes to the else statement. And that's the purpose of the else statement. It's kind of like another output, right? I don't know the best way to say that. It's just another, right? You have two types of outputs are returned to the console. You have either this one or you have this one. It's kind of like an A or a B. Okay? I'm going to leave it at that. Let's run. So you should know which one's going to execute. And it's going to say, oh man, back to work. Right? And that's true. Again, take note, guys. The compiler doesn't make mistakes. It's 99.999 repeating going to be true. It's going to be return truthful information to you. Anything that it gives that's messed up or the wrong, if you're seeing the incorrect input, it's a user error. Okay, guys? All right? There's nothing wrong with realizing that you went, oh man, I'm so silly, right? Because it happens. So there you go. And that basically explains enumerations. We've kind of done a little bit of code, guys. Created an if-else statement. I need a coffee so bad. Can't you tell? It's a coffee so bad day. Let's see what else we could do. Okay, so that was a demonstration of enumerated constants. And of course, we got the return of back to work because we're being explicit. We're saying today is Monday. This can be changed. There are ways to do it, but it takes a little more code writing, right? We're just being explicit here. And again, this is just like what's a symbolic constant, right? Symbolic constant. We're telling it what day it is, basically. Okay. So we can also, the enumerated constant shown here on this line, it's saying that it can be replaced with a series of constant integers. Okay? Again, with what I just said, if I go int number equals 12, we just basically created a const integer. Okay? Well, it doesn't change here, right? In this line, it doesn't change. That's why it's technically speaking a constant. Down your code, in your code, you can change the value, but that's based on like a arithmetic calculation of sorts. So they're saying that we can do something else here. We can go like this. Same programming, but using const integers. Okay, we're going to keep that part, but we're going to get rid of all this. We're kind of done with the enumerated stuff. And I'm just going to delete that. I'm going to keep my if-else statements. And so what we're doing here is I'm creating a bunch of local variables. Again, they're local to the main. We're calling them const because we don't want the value changed in code when we run it. Okay, so that's why we're using constant. We want to be able to access this value here without it ever being changed in code. So I'm going to go like this. 1, 2, 3, 4, 5, 6, 7, right? We should have 7 days. And then I go like this. I'm just kind of doing this quicker. Copy and paste. 4, 5, 6. Now the reason we end in 6, guys, is because remember, computers count starting from 0. Okay? Monday, Tuesday, wedding nest day, Thursday, and who doesn't love Friday or Saturday? Okay? So we're creating all constants. That means these values will never be changed in code, so they're indefinitely constants. Indefinitely. We're declaring its data type. And we've given them basically variable names, right? We can use that as variables. These are variables. Okay, now Sunday's holding the value 0. Monday's holding the value 1, 2, and so on. Okay, unsigned integers, I guess. We could say that they're unsigned as well. And another way of doing this is like this. Okay, I'm just showing you a different way. They're separated by commas though, okay? If you didn't want to waste all this space, you could do it what I call inline. We're basically telling the compiler, if you will, that all of these, now I could delete this, this is all inline. Okay? And we only have to write const unsigned int once. And then all we have to do is just create our variable names, separate them by commas, always end your statements with a semicolon. That's always common, always normal, guys, gals. Okay, semicolon. And nothing's changed. Oh, look, it put 2U, right? Because now we're being explicit that they're all unsigned, right? Right? If I get rid of the unsigned, we just don't want any negative values, right? Even though they can't ever be changed, but we can still be explicit like that. All right. So the next thing we have to do is we have to create a new data type. Today. What is today? Oh, I guess I have to assign it. So technically, we've assigned it or initialized it with the value 0. So that means today is always going to be Sunday, if you think about it. Right? If we don't add anything else. So if I run this, it should still run because remember, we're initializing it with these curly brackets. The curly brackets mean the value 0. Let me build this. So that means if today is Sunday, being 0, that means that this if statement is going to be true. Remember, this is or. Only one of them needs to be true. Okay, if they're both false, it's just going to jump to the else. All right, let me run this. It should say, yeah, bye-bye, it's the weekend. Let's go. Whoops, wrong one. It was still funny, though. Oh, my God. Can I make a coffee, guys? All right. Oh, I'm enjoying doing this. So much fun. Okay. So, and then here, if we want to be explicit and actually change what today is, we could say today is Tuesday. Okay? There we go. So now we've changed it. So now today is not 0 anymore. Today is actually Tuesday, which is the number 2. Okay, but obviously we could read this. This is human readable, right? And then, but the computer uses the integer values to do its checks. Okay? And running it, it should be back to work, right? Oh man, back to work. You guys see? A number of variables you declare in this program are not used. As such, your compiler might give you warnings when your compiler blah blah blah. We didn't have any issues. The output of this listing is identical blah blah blah. I'm not going to really go over all this redundant information that I feel like I've already explained, but here each of the constants, Sunday, Monday, and so on, was explicitly defined, right? Explicit. Okay? There's that word of the day, guys. Okay, coding lingo. Being explicit. You have to do that with the compiler. You got to think. The compiler isn't thinking what you're thinking. It can't read your mind. It can't understand what you want it to do. You have to be explicit and tell it what you want it to do. Okay? This is all part of the human interaction. Okay? And no enumerated days type exists, blah, blah. Okay, enumerated constants have the advantage of being self-documenting. The intent of the days enumerated type is immediately clear. Yeah. Well, it's all part of the human readable, too. Okay, today's lesson discussed numeric and character variables and constants. Basically, the last 2 videos is what we're talking about. Which are used by C++ to store data during the execution of your program. Numeric variables are either integral, being char, short, int, and long int, or they are floating point, right? There's the difference. Okay, that's some good information right there too. Let me just go like this, because that's good. That's some good information, which I actually might want to stick inside my my novel. Okay, numeric variables are either integral. Okay, this is the constant section, right? Numeric variables are either integral, being char, short int, and long int, or, I'll put a comma, tab it, or they are floating point, float double and long double, okay? That's just so you actually get that separation in your head, right? I'll leave that there. Okay. All right, carrying on. Numeric variables can also be signed or unsigned, as we've learned. Okay, that's kind of being explicit as well. If it's not stated as unsigned, then they're going to be automatically signed. Okay. All right, if we aren't explicit by saying unsigned like this, right here, this means signed. Okay, guys? Although all the types can be of various sizes among different computers, the type specifies an exact size on any given computer. You must declare a variable before it could be used. And then you must store the type of data that you've declared as correct for that variable. Right? Declare, initialize. Declare, initialize. If you're going to declare it to be an int, you have to use an integer or whole number value. That's what that meant. As an example here, okay? If you put a number that is too large into an integral variable, it wraps around and produces an incorrect result. That's why we went over this, guys and gals. Okay? All right? If you don't know what's being said here, I recommend you go back to whatever series video that was. Guys, the goal here with these lessons is to we're going gradually, following a course outline, and that's what we're doing here. This is kind of a free class for you guys and gals. If you're wanting to and desiring to learn C++, I fully 100% support you. I'm going to do my best to help you. Yeah. I'm just thinking, I'm going to explain things, maybe a little more than I need to, but I just want you to learn. I also want you to fully understand. If you do have any questions or concerns, just drop it down in the comments. I'll do my best to answer you. But it's great to have you, just to let you know. It truly is. Okay. So we talked about literal and symbolic constants. I don't need to go over that again. If a short int can run out of room and wrap around, why not always use long integers? Okay, you may ask. All integer types, this is part of the audio book right now, guys. All integer types can run out of room and wrap around, but a long integer does so with a much larger number. For example, a 2-byte unsigned, let me just bring this up so you can have that visual. Right? I almost wish I had a better visual for you, but hopefully that helps. It's got majority of them except for bool. Okay. Okay, just looking where I am. For example, a 2-byte unsigned short int wraps around after 65535, right? I hope you watch that. You'll understand. I'm not going to go over it again, guys, right? Lots to learn here, and we're trying to keep the train going, moving forward. Whereas a 4-byte unsigned long int does not wrap around until what is that? That's 4 million. Is it 4 billion? 4 billion. Yeah, it's 4 billion. 294. Remember, it's unsigned, right? Unsigned right here. Okay? It's kind of like adding these two together. These are all supposed to be commas, okay, guys? Ones place, tens place, hundreds place. Okay, if we add this number with this number, we should get this number. Or, yeah, we should. It looks like it. Okay? As soon as we took off the sign, as soon as we made it unsigned, no negatives, all positives, our range doubled. Right? However, on most machines, a long integer takes up twice as much memory every time you declare one. That's why I was always like wanting to use these kind, right? Because I was like, I want to be a good programmer. I want to use the least amount of memory as possible, right? We're all kind of like that in the beginning. Anyways. Well, you'll see a lot of people write code using just int. Okay, you'll see a lot of it. All right. However, on most machines, a long integer takes up twice as much memory every time you declare one, such as 4 bytes versus 2 bytes. And a program with 100 such variables consumes an extra 200 bytes of RAM. Right? You think about every time you declare something new, right? Each variable holds 4 containers, guys. 4 containers, each container is 1 byte. So think about that too, right? When you're writing your code. So frankly, this is less of a problem than it used to be because most I'm trying to read. Because most personal computers now come with millions, if not billions, of bytes of memory. And that's your RAM, guys, okay? What do I have? When I built my PC, I custom built and designed my PC. Because I have the brain cells and awesomeness to know how to do that kind of stuff. Not bragging. But I am pretty proud of myself. Oh yeah, that's on my Discord. I don't want to bring Discord up. I think I have 32 gigs, if I remember. I mean, I could bring up my system and that, but it's none of your beeswax what's on my computer. And don't worry, my computer can be checked. I'll be fine. I don't have to worry about those kind of things like some people. Not saying you guys, but there are those kind of people out there. All right? The weirdlies. I call them the weirdlies, can't control themselves. Okay, let's carry on. All right. Frankly, blah, blah, blah. Okay, so using larger types than you need might also require additional time for your computer's processor to process, right? Processors are getting faster. They can run multiple threads. Man, I wish I had a thread ripper. I've always wanted to build one, but, nobody wants to make me famous. You don't have to pay me. All you have to do is share the content and watch. Okay, let the advertisers pay. What happens if I assign a number with a decimal point to an integer rather than to a float? Consider the following line of code. Okay, so I'm going to clean this up. And what they've done is they went like this. We're using kind of camel case here, and we're declaring it as an int. Now, I don't think my compiler is going to complain, because it did complain, which is good. Is for what happened? System read the what redefinition? How did I mess that up? There's no shot. Is it that? Maybe could have been. Let me just see. Let's try it again. And they had 5.4. I think it was maybe the curly bracket I had there. Let me just see. Yeah, it was. I had a curly bracket there that was messing things up. You can see how, me deleting something can really mess things up too. Extra curly bracket. Okay, so it built. But if I standard C out it, if I just go a number, it'll return it to my console. But remember, we're saying that it's an integer, right, guys? Right? It's going to return an integer. So it rounded down. Okay, because it does round up and round down. Okay, so we have to be explicit and use the proper data type. Is it float that's less? Float has the least amount, right? Guys? Right? You're saying yes, right? How many of these things do I have open? Yeah, float's 4 bytes. So, there we go. Now it returns an actual float value. Floats actually you can be explicit with by typing F or F. Okay? That's common to see as well, guys. And I should have more practice doing that, but I work with integers more. Alright, a good compiler issues a warning. It really didn't with what I'm using. Again, we're using... Now, I don't know much about the compiler. Compiler is just a compiler to me. I know I'm using the C++ standard language, 20 standard, blah, 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 blah. Okay? I know that's what I'm using. Okay, the number you've assigned is truncated into an integer, which is true. That you've seen that, right? Truncated, rounded up, rounded down. Thus, if you assign 5.4 to an integer variable, that variable will have the value 5. Information will be lost, right? You lose that accuracy, I imagine. Especially with your calculations, I imagine you would lose that accuracy. Accuracy is important. SIGDIGs, guys, SIGDIGs. You'll know what I mean if you are good at mathematics. Thus, if you assign 5.4 to an integer variable, that blah, blah, information. However, and if you then try to assign the value in that integer variable to a float variable, the float variable will have only 5. I used float. Okay. And I don't know what they're trying to say there. But anyways, I showed you a good example of what happens when you return. If you use the correct data type. I didn't show you guys data types yet. Let me just see data types. We haven't really gone into that area yet, but let's see. Here we go. Okay, if I click this, okay, don't move. Here we go. Okay, data types. How values are stored into temporary RAM memory. Int. These are my suggestions. Int. Think integer values or whole numbers. char, think character. Okay? You guys can read all this if you like. Double. Double is a versatile. Okay? Real numbers. Float, a floating point. Double is called a floating point as well, if that's true in that statement, right? As a matter of fact, I could take this and add it to my section here. Floats. Maybe just paste it here for now. Good enough. Okay. Right. Floating point. Float, double, and long double. Okay, and I just say float, think decimal numbers. Again, a lot of it depends on how much memory you want to be used. It depends on what values and what numbers you're working with. Are you going to be in the, I don't know, 4 billions? I don't know. Things to think of, right? And also memory too, right? That's why I said, guys, okay? Which one uses more, which one allocates the least amount of memory? And that would be float. The range is different too, right? Double is like massively huge. Huge range. You can count. Try counting the stars in the sky. Okay? Good luck. Alright, there you go. Okay, I'll share this with you guys. Again, I have part of this, my book, my C++ book, if you will. I have it on GitHub. If you click the link in the description on YouTube, it's there for you. Okay. Why not use literal constants? Why go to the bother of using symbolic constants, right? I explained that part. Okay. What happens if I assign a negative number to an unsigned variable? Remember, as soon as you say unsigned, think positives only. Consider the following line of code. Okay, I'm going to go like this. Unsigned int. See, that's totally wrong what they're doing. Okay, here, we're breaking code. We're breaking code rules, guys. Even what we're typing here for a variable clearly tells us what it should be. Okay, unsigned int, a positive number equals -1. Does it argue when I build it? Nope. Let's see what happens when we return it to console. Let's see. Ah, there's the garbage right there, guys. Returns garbage. As a matter of fact, is that the 4 billion? How many zeros do we have? 3, 6, 9, 4.3 billion. There's the wrapping. That's the wrapping, guys. That's the wrapping. It went 9.5. Okay. I usually try I try to do things correctly. I don't try to break things deliberately. But right here, 295. Okay? 967,295. 967. Yeah, it returns the very last number. Things you learn, guys. Things you learn. It returned that number right there. Okay? That's what it did. We're breaking it. A good compiler issues a warning, but the assignment is legal. Oh, is it legal? Here we go. We're learning things. The negative number is assessed as a bit pattern and is assigned to the variable. Oh, a bit pattern. Okay. Things we haven't really talked about much. Bits and bytes. There is a section on it. Let's see. The value of that variable is then interpreted as an unsigned number, thus -1, whose bit pattern is... Okay, let me show you something. This is part of the bits and bytes. Again, we don't really need to be... I'm just going to go like this. Okay. Whoops. I'm not sure what I did there. Okay. I'm just going to tab it. Okay. And then... and then I'm just going to go... I don't know. I'm going to go like this. Whoops. Okay, I'm just going to go like that. So thus -1 whose bit pattern is this. Okay, well, all ones. So that's two. We have 8 bits is a byte. 1, 2, 3. There should be 8. 8 and 8. So this is 255, 255. 0x, FF, and hex. We're going to be getting into this a little bit, guys. I'm going to show you how to kind of convert forward and backwards in some code. Stay tuned. And is assessed as the unsigned value of 65535. Okay, but that's not what it returned to us, right? Maybe that's a 32-bit architecture. We ended up getting the value this. Again, take note, I'm on a 64-bit system, okay? That's probably the difference. On a 32 probably returns this. Again, we used unsigned int. I don't know. Unsigned int, a positive number equals -1. Okay, can I work with C++ without understanding bit patterns, binary arithmetic, and hexadecimal? Yes. The answer is yes. That's why I always say, guys, okay, you can know about something, right? It doesn't hurt to have, like, to know of the words, right? You don't need to go deep into the understanding. You don't need to go into the deep understanding of bit patterns. You don't need to go into the deep understanding of binary arithmetic. You don't need to go into the deep understanding of hexadecimal. But you do have to understand the memory part, and you got to understand the allocation, right? You do have to understand memory, okay? And the ranges. Okay? So the answer is yes. You can work with C++ without understanding any of that stuff, but not as effectively as if you do understand these topics. Of course, it doesn't hurt to have the knowledge and understanding. I think, I don't want to say you're going to be a better programmer. I'm not going to say that. But it helps to have that understanding and knowledge. I'll do some code in the future, guys, if you guys are interested. Keep following and watching and learning. I should take notes on remembering this sort of thing, but when we get to that area, I've done some binary math. When I took IT, you have to understand bits and bytes, okay? If you take IT or information technology. C++ does not do as good a job as some languages at protecting you from what the computer is really doing. Okay, this is actually a benefit because it provides you with tremendous power that other languages don't. Yeah, well, that's why I love C++, because, just at another level, literally, people, just at another level. As with any power tool, however, to get the most out of C++, you must understand how it works, right? Programmers who try to program in C++ without understanding the fundamentals of the binary system are confused by their results. Okay, we don't really have to get into the binary part much, guys, but what I've explained so far, however many videos, is the knowledge that you do need to know. Okay? And we'll do some binary stuff. Stay tuned. All right. Okay. If I give you this, I'm just going to do some copy and paste. If I give you this, all right. Given this enum, what is the value of blue? You should be able to answer that. If I give you this, okay, and I'm just gonna put these into a multi, okay. You should be able to answer these as well. Right? Just from the past videos we've done. Okay, which of the following variable names are good, which are bad, and which are invalid? I gotta finish up here, guys. Okay, what would be the correct variable type in which to store the following information? Right, so if I go like this, so there, you guys have that. I'm just gonna go like this, and just to, so that to save on, you know, typing and taking too long. Okay. What type of variables would you create? This is good practice for you guys. Okay. What type of variables would you use to create that? Okay. Again, you can use camel case. I know I kind of went over that video. I just got to find that section in my C++ book. Here we go. Okay, there we go. Here we go. Okay. Party size, snake case. It's typically used for private access modifiers, okay? We haven't done anything that's private yet, so don't worry about that. Party size, Pascal case, used for classes. We haven't done any classes yet. Party size, camel case, setters, getters, functions, methods is typically camel case. And then you got the Hungarian, which I would just avoid doing entirely. Const double, this would be private right here, the way it's written. Normally you would see, if you type in this link, it'll give you some good naming conventions here. I need to finish up. Okay, normally I'm typing my variables. Well, with an enum, I did it like this. That's fine. Int depends. Like these are public, so I'll just go number. It might be all lowercase, or you could use what they've been using. A number equals 12. Okay, for example. I would just practice with this style and this style, and then just practice coming up with your own names, you know, for example. Okay? With your own variable names. Because they say variable names, creating variables is one of the hardest things to do. Make sure it makes sense, right? Use variable names that make sense. Okay, and human readable. And what is it doing, right? Variables, like, what is the variable doing, right? Give it some motion, like some action. Create good variable names for this information. Declare a constant for pi as 3.14159. I've already kind of done that. Am I in that section here? Yeah. Here we go. I'll just do it for you. I'll just put it up here. What? Did I lose that? Oh, I must have. Okay, well, that's okay. Technically speaking, they are public variable. Local, I think. Local to int main. I kind of accidentally deleted it. Public and local variables to int main. Okay, there you go. That's kind of how I do my constants, like that. This underscore normally means like the M normally means like macro, but this isn't a macro. So declare a float variable and initialize it using your pi constant. Okay. Okay, there. It's all right there for you guys. Okay, and then so next video we're going to be getting into creating expressions and statements. So this is going to be fun. We're going to be working with, yeah, it's no different than doing, you know, basic mathematical type equations. Okay, I look forward to you guys showing up. Every single one of you awesome, beautiful people. Thank you for watching. I gotta bounce. I gotta go. Johnny Whiskey Tango Coding. I appreciate you. Thank you for the views and the support. Hopefully my instruction helped you a lot. That's kind of the goal. And I appreciate you. I'll see you guys in the next video. Whoever you are, wherever you are, take care for now. Have an awesome rest of your day, evening, night. Johnny Whiskey Tango Coding. That's it. Peace out, guys. Peace.
Baby, I don't understand this.